Welcome. In this video I'm going to show you how you can determine the alternative ratio using Python and the stikpetP library. If you want to see how it can be done without that library, there's a separate video on that. I'm using Python version 3.9.7 at the moment, but probably it will work on other versions as well. This video will focus on how to obtain the value, not so much on how to interpret this value. I'll leave a link to this Jupyter notebook in the description below. The alternative ratio is fairly simple, the proportion found in the sample divided by the expected proportion. It's an effect size measure that could be used after a one sample binomial or a one sample proportion test. To show you how to obtain the value using the stikpetP library, I'll first need an example, so I'll load that in using pandas. So first load in pandas and then load in the example data. The student statistics data is just some random generated, well, not fully random, but some data on some students collected once a long time ago when for the binary there was still male and female only, so I'll use that as my example, and there were 34 males and 12 females. So as you can see, there were a lot more males than females. Now the stikpetP library, you can install that by doing a pip install and then use this link, which is to my GitHub account, and then just import it as any other library. I'll use synonym PS, for those are my initials, just to avoid having to write down stikpetP every time. The function of interest is ES, effect size, alternative ratio, with underscores in between. It has a few parameters, the data of course, code, so if you have more than 2 categories you can select the 2 that you're interested in. The expected proportion or hypothesized proportion, by default it will be set to 0.5, and you can define which category you seem as success, and otherwise it will simply use the first category it finds. For more information, put a question mark in front of the function and you'll get the info from there, or just click on the link over here. Now let's take it for a spin, and if I use my example data, I'll notice that there is a alternative ratio of 1.48 and 0.52. You might notice that this is actually how far the difference is both the same if you set 1 as the center. So, and that's it. That's how you can determine the alternative ratio. Again, if you want to do it without libraries, watch my other video, and these are the sources that I actually used for this. Alright, I hope this was helpful, and thank you for watching.